Hello, my name is Adrian, and together with Angel and Eduardo are going to explain the Bernoulli's principle and share a little experiment we did with.
What is a fluid? In essence, a fluid is a substance that has no fixed shape and yields easily to external pressure. Basically, it means that fluid possesses the characteristic of adapting to any amount of volume independent from the shape of the object, a part that is easily susceptible to changes in its pressure.
The physical properties of fluids are compressibility, which is a measure of the volume change of a fluid or a solid as a response to a pressure change. Density, the amount of matter in a definite space. Pressure is defined as a normal force acting on an area. Buoyancy is an upward force exerted by a fluid on an immersed object in a gravity field. For example, is the reason why a submerged body has the ability to float and not to sink. And finally, viscosity is a measure of its resistance to deformation at a given rate. For example, honey is thicker than water and resists more to being deformed. Um, Among its applications, we have that we can take advantage of air as a fluid to fly airplanes, which is the principle that makes them fly. And we can take also advantage of fluids to uh, exert pressure on them and to have as a result enormous forces which can help us lift big weights. So now that we know the applications and properties, we can talk about Bernoulli's principle. In fluid dynamics, Bernoulli's principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in static pressure or decrease in the fluid's potential energy. We can see that it is given by the Bernoulli's equation, which is P1 plus a half of PV1 squared plus PGH1 is equal to P2 plus 1.5 of PV2 squared plus PG second H. Uh, and this equation basically tells us that fast moving air will produce less pressure and slow moving air will produce more pressure. And as we can see, the resulting net force will make an airplane wing fly as air is passing through.
This is the experiment we decided to do. We are going to explain the phenomena seen in the video and interpret it with the statement of the Bernoulli's principle. The materials we used was a hairdryer, a ping pong ball, and the steps was to connect the hairdryer, then place the ball in the middle of the air exit and turn it on.
This is the experiment for the Bernoulli's principle.
So as we seen in the video, we can analyze it by saying that as you move the hairdryer, you can make the ball follow the stream of air because of Bernoulli's principle, which says that the fast moving air around the sides of the ball is at lower pressure than the surrounding stationary air. So the ball will float in the flow no matter how you move.
Like in our experiment, we can observe that the fast movement of air increase of air creates areas of low pressure and high pressure, and in the first two images we saw how the man is blowing air rapidly to the space between the cans, creating an area of low pressure, which makes the pressure around the cans be higher or no area of high pressure, and thus make the cans move with another as seen in the second image. The same analysis applies for the two images, but now this is time with a hair dryer.
So basically, we can see that the resultant net force of the pressure will make the cans stick together. And also on the images from the bottom, we can see that the slides will close to each other because fast moving air will create a space of low pressure.
Have you ever wondered why balls in many sports tend to curve in a fashion way? It is called the Magnus effect, and this is a direct result of Bernoulli's principle. As we can see in the picture, the wind is blowing as normal, and then the ball goes rolling. So the faster the wind speed is, the lower pressure it will apply. The slower wind speed, the higher pressure it would apply.
So the resultant net force will tend to move the ball to the left.
This equation and principle is one of the fundamentals of in fluid dynamics. Its applications help us describe motion of fluids. Thanks to it, many phenomena of this area can be explained and be taken advantage of video developing impressive technology with it.